Number 14. So we are officially into section 2 of chapter 11. Talked about the ideal gas law. Ideal gas law. A lot of people are intimidated by the ideal gas law. I don't want you to be. The ideal gas law itself is not super complicated. It's PV is equal to nRT. Now, if anything, I would understand that you could be intimidated by the scope of which ideal gas laws can prompt you to think, right? That might be intimidating. There are a lot of different things that you can do in terms of asking a student to accomplish something. Do you solve for one of those? Do you calculate a molar mass? Do you calculate a density? Do I ask you a question about this constant? Right? There are a lot of different things I can ask you about this. I mean, this could be the gateway into just doing a stoichiometric calculation, and on top of that stoichiometric calculation, do like a theoretical yield limiting reactant type of problem. Just so many options here for me as someone who's assessing you, thinking of different questions I can ask you. There's a lot of different things, so that could be intimidating. I guess I could understand, but the actual law itself is pretty simple. All right. So number 14, calculate the pressure in atmospheres. So all of my answers need to be in ATM. Let's see, I'm on the screen, right? Yeah. Exerted by each of the following. Now, if you need some extra help, boom, there's some help for you. So A, 2.5 liters of hydrogen fluoride containing 1.35 moles at 320 K. And so what do I have here? I have volume, I have number of moles, and I have temperature. Okay. You might think I have 1, 2, 3 of the values. I'm being asked for the fourth one, but I don't know what R is. Okay. Now, R is the ideal gas constant. Ideal gas constant. It's always going to be the same number. However, please remember that the value that we use for is going to depend on the units that we're using in the ideal gas equation. Now, if this is really being difficult for you, I suggest you work these problems out with your book open to this table right here. Okay, it's on page 342. These are the different values of R, and you can see, you can see I have the different numerical values for R, depending on what units we're using for pressure. Okay, what units we're using for pressure. Now, there's not a lot of variation in what we do with units for volume. There's not a lot of variation for units we use for temperature, obviously, because we're talking about gases, so we want to use the kinetic molecular theory, and so we want to use kelvins. Units for moles. The thing that usually varies is going to be your unit for pressure. Okay, so if you need these values, check out this table as you practice. So I will keep that page open because I don't remember what they are off the top of my head most of the time. All right, so we know what R is as well. R, in this case, I'm using ATM, liters, moles, and kelvins. So that means I'm going to use one of the most common versions of R, which is going to be 0.0821. And it's going to be liters, atmospheres, Kelvin. So that's what I'm going to plug in. All right, so I'm solving for pressure. Let's rearrange this for pressure. I need to get that volume out of there. So I'll divide both sides by volume. So I have pressure is equal to nRT divided by volume. So let's try that out. Pressure is equal to nRT over volume. That's 3.15 moles. And then 0.0821 liters, atmospheres, moles, Kelvin times 320 K all over my volume of 2.50 liters. Now check out this magic. Notice I have a moles right there and a moles on a denominator. They cancel, they go away. Notice I have a liters on a numerator and on a denominator. They go away. Notice I have kelvins on a numerator and a denominator. They go away. And you see that the only unit left in this whole gobbledygook is atmospheres, right? So we need to make sure that we're using the right value for R, and this is one of the ways that you can do that. You can just make sure that. But we're ready to calculate. 1.35 times 0.0821 times 320, and then divide by 2.5. We come up with, let's see, I want 3 sig figs, right? So that 8 is going to turn that 1 to a 2. 14.2 ATM. That wasn't so bad. The worst part about this, honestly, is finding enough space and writing in all these units so that I can show you that they're actually canceling. That's the most annoying part, but that's actually not so bad in the grand scheme of things. Now, B. So, again, we have volume, we have number of moles, and we have temperature. Okay, so it's going to be the same setup, So we already have pressure is equal to N RT over V. So my value for N, 0.86 moles. My value for R, liters, atmospheres over moles, Kelvin. 300 K. And what was my volume? 4.75. And again, moles cancels with moles, liters with liters, K with K. And the only unit that doesn't cancel in here is ATM. And it's time to calculate. Oh, I'm not doing a log, so I'm going to press that button. Alright, so 0.86 times 0.0821 times 300 divided by 4.75. And again, 2 sig figs. Oh no, 2 sig figs right there. So that's going to be that 4 spot right there. That 5 tells me to turn that up. 4.5 ATM. All right, C. Let's get that up just a little bit. So we have a volume. It's in milliliters. This should be a superscript. We have a value for N, and we have a value for T. Now, there are 2 units that I don't like in here. Okay, first off, that degrees Celsius, I want that to be in Kelvin, so I'm going to add 273 to it. All right, so that's going to be 330. Is that right? $330K? That's right? Yeah. Why is this not making sense in my head? Come on, calculator, come to my rescue. 273 plus 57. Yeah. This bad boy over here, however, is in milliliters. And if I'm going to do all my cancel magic, I'm going to need my volume to be in liters. And so what I am going to do is I'm simply going to move this decimal to the left 3 times. 1, 2, 3. into liters. If you don't believe me, you can do your own conversion factor to turn those milliliters into liters. You can do that pretty simply. Remember that 1 liter is equal to 1,000 milliliters, if that's something that you want to check out on your own, if you don't believe me, but here we go. Pressure is equal to nRT. Remember, I'm using this version of the equation because I already solved for it way up here. Okay. Value for N, 2.15 moles. Value for R, 0.0821 liters, atmospheres over moles, Kelvin, and then 330 K. And then I'm using that volume in liters. Again, I really like to go through and check off all these things off my list to make sure that I'm not messing them up. And it's time to calculate. And what am I doing? I'm doing 3 sig figs this time, right? 3 sig figs, yeah. So 2 times 0.0821 times 330 divided by 0.0075. All right, 3 sig figs. That's that spot right there. That 6 tells me to round that up. I go 7770 ATM to make sure I have the correct number of sig figs.